There are many different functional groups in organic chemistry. A functional group is a specific arrangement of atoms which have specific chemical behaviors. Before we can talk about the specifics, we must first understand how covalent bonds work, as well as how an element determines how many bonds it can make. Take oxygen as an example. The electronic configuration of oxygen is 1s2, 2s2, 2p4. This equates to 6 electrons on the valence electron shell, and to fill up the remaining 2 electrons, the atom can form 2 covalent bonds. Remember how a covalent bond was the sharing of 2 electrons between 2 atoms. Therefore, each covalent bond formed is effectively 1 extra electron from a neighboring atom. The same argument works for elements like nitrogen, which can form 3 covalent bonds, carbon, which can form 4. With this framework, we can now quickly run through the basic functional groups. In this video, I will not be talking about their respective chemistry, but they will be covered in future videos. The most basic functional group is the hydrocarbons. By definition, hydrocarbons contain hydrogen and carbon atoms only, and are the building blocks of organic chemistry. Fully saturated carbon and hydrogen are alkanes, or alkyl groups. If the carbons are double bonded to each other, that is called an alkene, or alkenyl groups. And if they are triply bonded, it's called an alkyne, or alkynyl groups. There's a fancier functional group called aromatics, but it is too complicated for this video. The first group we'll go through is oxygen-containing functional groups. As we have discussed, oxygen can bond twice. If both bonds are connected to hydrogens, this molecule is called H2O, or water. It is the substance that allows life to prosper on Earth. If one of these hydrogen is substituted with an alkyl group, it is known as an alcohol. The active ingredient that causes tipsiness in beer or wine is ethanol, or ethyl alcohol. If both hydrogens are substituted with alkyl groups, it is classed as an ether. Ethers are widely used as organic solvents in synthetic chemistry. The most used one is diethyl ether. Next, we'll go through the nitrogen-containing functional groups. Nitrogen can form 3 bonds. If all 3 are hydrogens, we call it ammonia. Ammonia is a pungent-smelling compound that are often created by nitrogen-fixing bacteria found in decaying leaf petals. If one of the hydrogens were substituted with carbon, it is known as a primary amine. And quite as expected, if 2 carbon was substituted, it is secondary amine, and if all hydrogens are substituted, it is tertiary amine. Amines are synthetically important because it is found in most bioactive compounds and drug molecules. And finally, we'll go through the halogens. Halogens are group 7 elements, or group 17 if you use IUPAC conventions. These elements form single bonds almost exclusively. In terms of naming, it is dependent on the group that they are attached on. For example, if a chlorine is attached to an alkyl chain, we call it an alkyl chloride, whereas if chlorine is attached to an aromatic ring, such as benzene, we call it an aryl chloride. For fluorine, bromine, and iodine, the associated names are fluoride, bromide, and iodide respectively. This about wraps up this video. There are a lot more functional groups that I haven't described. They will be covered in another video. I hope this is useful, and I hope to see you again next time.